Welcome back to my channel and welcome to yet another BALTIC AQUASCAPHE video. These videos are actually piling up. I will link all the videos down below in the description if you want to see the other ones. In this video we are going to look at the precision and accuracy of the BALTIC AQUASCAPHE, or more precise, the precision and accuracy of the built-in Miyota 9039 movement. Since its launch, there have been questions about how precise that movement actually is, and people commented a lot that they would prefer BALTIC to release the watch with a Swiss movement instead of a Japanese movement. And in this video we're going to put the watch on a Timegrapher and go through all the positions and measure them to give you an idea on how precise this watch actually is and can be. And we're also going to look at how precise Miyota expects this movement to be. So let's jump into it. The movement that we find in the BALTIC AQUASCAPHE is the Miyota 9039 movement. It is an automatic and hand-wound movement that's also hackable, which means that the moment you pull the crown, the second hand stops so that you can precisely set the watch or the time to the second. The watch has an interesting feature that I really like. It's fully jeweled all the way through, right down to the barrel. As you can see here, roughly between the 12 and the 1 o'clock position, you have the barrel jewel. So the watch actually should be pretty reliable and also, pretty precise. Yet Miyotas are not actually known to be chronometers. To get a better understanding on how precise the movement actually is, we're going to look at this fact sheet, which comes directly from Miyota, and which shows what they expect for this movement in terms of accuracy. So what we can see here, and what I've colored in green, is that Miyota expects the accuracy of the movement to be in between -10 and +30 seconds a day. That is what the movement should actually do within all positions if we measure it through. And that's what we're going to test on the Timegrapher just in a minute. What they also expect is what they call a posture difference. I presume that this means in actual daily wear, the watch should not deviate more than 40 seconds from the actual time. To be able to see the results on the Timegrapher, I'm going to give you a short introduction on how a Timegrapher actually works. You place the watch on a microphone, and that microphone measures the tick-tack of the movement and puts it into a graph and gives you also all the other relevant information. What we can see here on the actual Timegrapher from left to right is the deviation in seconds that has been measured. In this case, it's 18 seconds a day, or plus 18 seconds a day to be more precise. The next number, 241 degrees, is the amplitude of the balance wheel within the movement. And that gives you a rough indication on how good the watch is actually running, more precise, how much energy the balance actually gets from the movement. So the number should be over 200. It depends a little bit on the movement, but you're looking on mid to high 200 numbers. The next thing is 0.2 ms, which is a short abbreviation for milliseconds, and that is the indication for the beat error. If you're not really familiar with a watch escapement, explaining a beat error is a little bit difficult. Beat error at best should be 0.0. In very expensive watches, it almost always is 0.0. In less expensive watches like here, that's going to be 0.1, 0.2. You can regulate it down. You should if you can, and in this movement you actually can do that. So best result here would be a 0.0, but it's not really a tiebreaker. And the last thing that we're going to see on the right is 28,800, and that's the number of amplitudes, the vibrations per hour that the movement actually does. Also, that number changes to a 51 in just a second, and that just means the lift angle, which is a number that you have to adjust depending on the movement that you are measuring, because that is really actually something that is different in every single movement. So what we want to see in this video is, does the BALTIC AQUASCAPHE actually hit on the goal of -10 +30 seconds a day, or a posture difference of 40 seconds a day? And what else can we learn from these measurements? With that, we're just going to measure the watch. Okay, first position we're going to measure the watch in is glass up. That is the position that you most likely will wear your watch when you're on a desk, or it's also the position that you're most likely to put your watch down on a nightstand or something like that. And we're looking here at about 20 seconds a day deviation, 235 degrees of amplitude, which is okay, and 0.2 milliseconds of beat error. I suspect that the beat error will not really change during all the other positions. Second position is glass down, so pretty much the exact opposite. Now we're looking at plus 18 seconds a day, still 235 degrees of amplitude and 0.2 milliseconds of beat error. Oh yeah, now we're down to plus 16 seconds a day, still within the guidelines of minus 10 plus 30 seconds. There it goes up to plus 18 again. So yeah, it's right about that. That usually takes a little time to set in. 20 degrees of amplitude. Oh, let's switch to the next one. Now we have the crown in the right position. We are looking at plus 14 seconds a day, 230 degrees. It's not much deviation in amplitude. 5 to 10 degrees, it's not that bad. Now we're looking at 0.3 milliseconds of beat error. That's a little high. That could be less. I don't know what the specs are for Miyota, but yeah. Now we are looking at the crown on the left position, which is the opposite here. Again, plus 16 seconds, 232 degrees, 26 seconds, 0.0 milliseconds of beat error. That's good. That's what we actually want to see. Yeah, plus 22. Still within the expectations for Miyota. $227. Yeah, that amplitude is going around a little bit, but that's okay. What we don't want to see in a changes of amplitude is a massive drop or a massive increase in amplitude. That's not what we're going to see. Next position is crown on the upward position. This is most likely, you know, if you're wearing your watch on your right wrist, this is the watch that the position is probably most likely to be in most of the time. We're looking at plus 18 seconds a day, 227 degrees of amplitude and 0.2 milliseconds. So there's not much of a change here. Again, 12 seconds a day is okay. That is actually good that we have less than 20 seconds here, because this position and the next one that's going to come, these are the positions that you usually have your watch in when you're just wearing it while standing or walking. So if you have an active lifestyle, that's the position your watch is in probably most of the time. Yeah, now we have last position is crown on the down position. Let's give that a little time. Yeah. Now we have an increase from plus 12 to plus 22. Let's see if that comes back down again. Plus 20 seconds. Still within the guideline, but the change has been a little bit significant. Drop to 209. Putting a watch on a Timegrapher usually takes a couple of seconds, half a minute to adjust to the new position. That's why it's not really telling you anything on how your watch behaves on your wrist. Yeah, plus 16, 209 degrees and 0.1 milliseconds of beat error. Okay, I just wrote down all the results and here they are. Let's just look at that. Okay, let's just look at the results. If we take all the deviations in seconds together and build an average, we're looking at plus 17.16 seconds a day, which is pretty good. It's definitely within the expectations of minus 10 to plus 30 seconds a day, and also within the, well, active wear deviations of a range of 40 seconds a day. If we're looking at the amplitude, we are looking at an average amplitude of 226 degrees, ranging from 210 to 235, which is, for a new watch, pretty okay. It would have been really terrifying if we would have seen something like high 200s and then very low 200s, or even somewhere in the region of 190 or something like that. That would really clearly indicate that there is something wrong with the movement, and that the energy within the movement is not correctly flowing and reaching the balance. And probably then we would also see a very significant deviation in precision. 17.1 seconds a day sounds pretty good. I will give you an idea on what that actually means in daily life, and that is really a little bit different than the specs on paper. The same watch that we just measured, I'm wearing for a little over a year every single day. And what I observed on my watch is roughly a deviation of about a minute a day. So it's closer to the range of 40 seconds a day that has been set by Miyota. What that clearly shows is that precision always depends, one, on your climate, because temperature has a direct effect on your watch, but also how you actually wear it. So lifestyle differences can make up a very significant difference in precision from one person to another. So if you buy a watch like this and after 3 months you find yourself consistently resetting the watch to an original time because it's going too fast or too slow, what you can do is to go to your watchmaker and adjust for that. For example, if you're wearing the same watch every day for 4 months and you consistently recognize that every 3 days you have to set the watch a minute back, you can go to a watchmaker and say, hey, I've realized this pattern, can you please adjust or regulate the watch accordingly? Because the watch right out of the box really is a little bit something different than on your wrist. If you're 8+ hours a day sitting on a desk, your watch will go very differently if you are working construction or, running a lot or something like that. My conclusion is I'm really quite happy with that. If my watch gets a service in about 2 or 3 years, I will adjust the regulation to my daily habits. Yeah, thank you for watching. If you want to see all the other BALTIC AQUASCAPHE videos, I've linked them down in the description, and I see you in the next video.